All right, let's talk about how to perform a hypothesis test for dependent data. We're going to use RGuroo as our tool to perform the test. But before, let's talk about what does it mean to do a hypothesis test for the mean of dependent data. So in this case, the data is set to be pairs. So what we do is we're going to make an inference on the difference between the two means for the two groups. I can talk about this a little bit more once I have the data, once we move from here. So let's just read about this. Let's see what the problem is saying, and then let's talk about the hypothesis. A bioengineering firm was working to increase the yield of eggplant crops, and it developed two promising strains of eggplants. In early tests, strain A appeared to produce a slightly larger yield than strain B, but the difference was too small to be significant. The company decided to check that strain A produced more than strain B by replicating the test on a much larger scale. Company planted the crops in 30 different fields. The fields were randomly assigned a density at which the seeds were planted, with half of each field growing one of the two strains of eggplants. The firm tests the pair data where alpha equals 0.01 in order to evaluate the claim that the true mean difference between the yield of strain A and the yield of strain B, it's greater than 0. So then here you see true mean difference. Now we're not talking about mean of group 1 being different than mean of group 2, or that mean of group 1 it's bigger or smaller. We're talking about the difference. But at the end, that's what we are calculating. We're subtracting one from another. So from the problem, what are our alternatives? So same as when we perform hypothesis tests for two means, when we know or we don't know the standard deviation of the population, our new hypothesis is that the two means are the same, right? So when we say that the two means are the same, if I subtract two numbers that are the same, then the difference is going to be equal to 0. And that is our null hypothesis always. The mean for the difference is going to be equal to 0 for our null hypothesis. Now the alternative is our claim. So the alternative, the claim, is that the mean difference between the two strains is greater than 0. So we're doing a right tail. The mean difference is greater than 0. And this in here is my combo of a null hypothesis and alternative hypothesis. So we're going to submit that so that we get our data. So we need, so we can talk about this. All right. So again, I have 30 pairs, right? Because they did the study, or they replicated the experiment in 30 different fields, right? So here we have the different fields, and then they have the grown. This is the height of the plant for strain A and for strain B for all 30 fields. Remember, they did kind of a 50-50 in each of the 30 fields that they choose. So again, we don't need to calculate the difference because RGuroo is going to do that for us. If we use Excel or any other tool, we'll have to add a new column in here, and we will have to subtract strain A minus B. So we have to do 3.7 minus 3.9. We get a new number. 4.4 minus 4.5, and we get a new number, and so on. So let's just download the CSV and let's talk about what we are doing. I am going to import my data to RGuroo. So let me just use this. Let me do strain AB as a name. So again, we don't need the summary. Okay, so here, if I want to add, let's say, just a new variable. So when we add the variable, we can calculate the difference. Okay, so we calculate all of the differences in here. The difference will be just subtracting a minus b 30 times. We have a new column. That column is the column that we call D. That's the column that we call the difference in between A and B. And we are talking about that mean, all right? That mean can be positive, can be negative, can be something near zero. If it's something near zero, then it's because the means for A and B are actually pretty much the same. That's what we test. We are going to test if that difference is significant, statistically significant. So to conduct the test, we go to the analytics, and we go to analysis, and we go to mean inference, and we go to the two populations again. We select our data set. The difference here, I'm doing A minus B. So A goes here, B goes here, B goes here. Okay, so we have stain A, stain B on all that. We have pair data, so it's dependent. So every time we're working with something that it's pair data, we need to click in here. All right, when you do this, you see how it changed to strain A minus strain B. Let's see what happens if I do it the other way around. If I do, now I cannot change it. Okay, so let's start. So I choose my data set and I say that stain B is variable 1, stain A is variable B. When I do the pair data, the label change, and now I'm doing B minus A. This is totally different than A minus B, so we need to be very careful. So I'm going to go back here, choose my data set, and choose this in order is A minus B. So when I do pair, I get that order. All right, this is the mean difference. All right, so this 0.05 is the mean for that new column that we're calling difference. This is the standard deviation, and we have 30. We go to population 1, 2 again because we want to do a test of hypothesis. The alpha that was given to us was 0.01. And here you see how it changed to mu difference. And we're going to use our alternative hypothesis. And we say this is greater than 0. All right, it's pair data. We don't know the standard deviation of our population, so this is also a t-test of our method. We click in here, and this is giving us everything related to the difference, all right? So here you have the mean high for strain A, the mean high from strain B, and this is the difference in between the height, the mean difference in between the height. So here we have a observed t-statistic, which is what we need here. We need 2 decimal places, so that is 0.88. And then we need a p-value, and we need 3 decimal places for this p-value. This p-value is right here. So in here we write 0.192. The next one is a 4, so we don't round. All right. Once we have that, we need to write our conclusion. We have a p-value of 0.192. The p-value is bigger than my alpha of 0.01. So we fail to reject the null hypothesis. We fail to reject the null hypothesis that the true mean difference between the GO of strain A and the GO of strain B is equal to 0. We cannot reject that null hypothesis of the mean difference being equal to 0. And when we fail to reject, it's because there is not enough evidence to conclude that the true mean difference between the stains is greater than 0. So we fail to reject, we don't have enough evidence. When we reject, it's because we have the evidence to reject. We click submit, and that's how you perform the test using RGuroo.